So here we wrote down a bunch of sets, and we wrote them down by writing down their elements in braces, or sometimes not even doing that. But I want to introduce a really useful notation for writing down sets, which is called set builder notation. And how does this work? The way this works is that you write curly braces, just like usual. But this time you get two slots. You get a place where you say what the elements are, and then you have a place where you say some requirements, or extra information about what the elements are and requirements they have to satisfy. So I think it'll be most clear if we just do a bunch of examples. So the even integers we can write using set builder notation as n in z. So remember, this is our notation for an element or contained in. And this thing is the integers. Let's just bring that down real fast so we have the integers in view. So even integers are elements of the integers such that n is equal to 2k for some k. And let me say k should be an integer as well. So what is this saying? This is saying that the elements of the set we're defining are integers satisfying the requirement that there is an integer k where n is equal to 2 times k. So this is a lot of new notation, but if you have the notation in front of you and you sit down and unwind it, this is saying that these are the even integers. And let me write this down in another way. You could also write this as 2n for n in z. Okay, this is a little bit more compact way to write it down. But what we're saying here, our elements have the form 2n, and n is running over integers. So somehow our elements are 2n, where n is required to be an integer. So there's many, as you can already see, there's many, many ways of writing these things down. But if you just keep in mind that these are the elements, and these are telling you about the elements, whatever you need to know, that'll do it for you. And again, just a lot of practice, and seeing it enough times, you'll become used to it. Let's do another one, the rational numbers. We can write as, so we're calling them q, let's write that. But we can also write them as elements of the form r over s, where r and s are integers. Actually, and let me say s is not 0. Right? Because every rational number can be written as a fraction where the top and bottom are integers and the bottom is not 0. So this is just telling us how we write down rational numbers. And let me also point out sets forget about duplicates. So it doesn't matter that we wrote this down with duplicates, the set forgets the duplicates. So for example, 1 over 1 is equal to 2 over 2, which is equal to negative 2 over negative 2, and so on. That's fine. We just get one element of the set corresponding to all of these duplicates. No problem there.